All right, hello everybody. We are going to be working, and all you're going to be able to see is a spreadsheet for reasons I cannot explain. The software is not working properly, but I am working from the 6.2.2 checkup problems here in Algebra 1. So if you want to follow along, just go on those checkup problems as I go back and forth. First question is talking about for questions 1 through 4, use the following data to calculate and interpret the linear regression equation. So gives the worldwide carbon dioxide emissions have increased over the years as Earth's population has grown. The table shows the world carbon dioxide emissions in millions of metric tons from 1950 to 1990. Excuse me. So question 1 is talking about which is the explanatory variable and which is a response variable. Well, the explanatory variable is your y. Your x. I'm an idiot. Explanatory is always your x, ex there. So time in years will be 1950, 1960, 70, 80, and 90. And then your response variable is then your y value, which is your emissions. So you have an x for year and y for emissions. Again, I'm on the 6.2.2 checkup problems. I'm just talking right from that. So the first one, explanatory, which is always your x, and the response is your y. And then the second question is where we need to use this spreadsheet. So calculate the linear regression equation from the above data. So what I'm going to do is I'm going to paste data. So I pasted the data straight directly from the checkup problems, and now it's on the spreadsheet. And what I'm going to do with this stuff, kind of click over here, and I'm in a Google Sheet. So you have access to Google Sheets on your Chromebook. I think there could just be like the green button similar to this. Looks like that. It should be on the bottom of your Chromebook or side or wherever your little bar is, your dock bar, whatever the heck it's called. Or to go sheets.google.com, or on like your email on this corner, you usually have that little waffle, that little square box of 9 dots. Click that and you can find sheets. So you should be able to get that. If you can't get the sheets, just let me know. I'll help you out. So randomly I have my data. I'm going to go insert and I'm going to go chart. Insert chart. All right. First thing I want to do, come over here to chart type. We'll switch this to a scatter plot. Scroll down. There's a scatter. I click that. All right. I need to select my data. So what I do is I click this little box and I'm going to click and hold. I'm still holding the 50. I'm going to drag down with my other finger and select, and then I let go. I'll come over here. I'm going to add another range. Click, hold, drag. So I have my X's and my Y's. Click OK, and there we have a scatter plot. All right. Now what we need to do though is we come down, we go over here to customize. So I'm going to click customize. And I want to go to series. Scroll down, and I want to click here trend line. So this will give me a line of best fit. So this gave me the line of best fit. I'm going to scroll down here. I want to show R squared, and then label. I want to use the equation. And what we are given here is we are given the equation. So our regression equation, which is going to be 428x minus 8,280 or 828,700. Excuse me. So this right here gives me my equation. How we would write this is just y equals 428x minus 828,7,000. The comma is probably not necessary. Then you have your r squared value as well, which is 0.993. So again, I came here. There we go. Sorry to get my chart back. I went to customize. I scrolled down to series. I turned my trend line on. My label went to use equation, and I showed my R value, and that gives you the information you want. So that answers your question 2 for you. All right, so that answers question 2. What is the linear regression equation? That's what we just got, just from Google Sheets. What does the slope mean in context? So our slope, remember, is always that number in front of the x. So it's that 428. 428 is my slope. And what that means in the context of this problem is that each year, the amount of carbon dioxide emitted increases by 428 million metric tons. And remember, it's million metric tons because that's what the table showed. And that's in the instructions on the checkup problem. So it increases by 428. So each year, as the years go up, the carbon dioxide emissions increase. Now they want us to estimate the emissions in 1978. So what we're going to do, excuse me, sorry. So what we're going to do is, so 1978, click an empty box. I'm going to go equal sign 428 times 1978. I feel like I'm doing this wrong, but I'll be okay. No, I'm right. We're good. And there we go. So they wanted 1978. Well, 78, or the X values were my years. So I just plugged years into my formula that I got. They gave us a formula by getting this trend line in the scatter plot. I then just calculated. You have to have an equal sign for Excel, or if you want to do this on your own calculator, you could have done that as well. So it's just 428 times my X value. In this case, my X value was 1978. Then I subtracted my Y-intercept, which again I got from this equation. All right, so that answers the first 4 questions on that checkup problem. Now let's go down to questions 5 through 7. It says use the data in the table and the regression lines from question 2. So we're using that equation that we just found to calculate and analyze the residuals. So what we're going to do is we're going to take this, I'm going to copy, I'm going to bring it over here so it's kind of on the same place for us. All right, so what they want us to do is they want us to find the predicted amount. So this is the actual amounts and then the predicted amount. So what's the difference between the actual and the predicted? So obviously this is stemming from data that we already have. So we already had all this data, and now we're predicting it. Why are we predicting something that already happened? This is more to organize our equation to see if it kind of works, and then we can start predicting things going forward. So how are we going to predict this stuff? Is I'm going to click an equal sign here. I'm going to click 428 times, and then I'm not going to type in 1950. I'm going to click that answer. So I clicked 1950. If you see, it says J3. So because it's in the column and row, J3, so 1950. And then I still have to subtract my Y-intercept. And what that gave me is my predicted value. And I'm going to go ahead and click this box with 428 J3. And I'm going to click this bottom right corner. I'm holding it. I'm going to drag it down. And what that does is now this predicted value is coming from J4. Well, J4 was the year for this row. And it's going to go down to J5, J6. So when you set this up and you drag it, it ends up just predicting going down. So what this means is our equation that we calculated, or that we found using the line of best fit in the scatter plot, the equation would predict that you'd have 5,900 emissions when they actually had 6,000. This one predicted us to have 10,180, but we actually only had 9,500, etc., etc. So we now need to calculate the residuals. Well, how do you calculate the residuals? Well, a residual is simply the actual amount minus the predicted amount. So I clicked an equal sign, I clicked my actual amount, and I subtracted my predicted. And then what I'm going to do, click that, and I'm going to drag it down. And these are all my residuals. So you can see the first one wasn't too far off, but then the next few were were kind of significantly off. I guess it depends on, you're talking about these are all 540 million metric tons. I think that's how they're measuring it. So they're kind of off, but because I'm not that smart to know how off they are in terms of a real life scenario. So we calculated predicted emissions. We did that here, right? And I showed you the formula. We did that. We calculated the residuals for each year. And now we want to plot the residuals on the residual plot. So if you're looking at question 7 on your checkup problem, the 6.22 checkup problems, if you look at that chart, what you want to do is at like 1950, you want to go up to 100. You want to put it from 1950 to 100, you want to put a point. Then 1960, you want to go down negative 680. So you have one dot close to the line above, one dot really far down below. And then 1970, you want to go really far up for 1980. And then 1990 goes back down. So residual plot, you're just kind of plotting above and below the x-axis based upon whatever that residual is. And then, and I can't, I'm sorry, but I can't actually show that to you because of limitations right now. So you're just plotting those points. So you do the year 1950 on that plot, again, question 7 on your checkup problems. And then you're going to go the x value at 1950, the y value 100, the x value 1960, the y value negative 680, et cetera, et cetera, et cetera. And what we see when you do that is we have some above, some below. This tells us that it is a good linear fit because there's no obvious pattern. There's some above, there's some below. There's nothing that looks like it's trending in the same direction. It looks like it's kind of is predicting. Obviously, we're going to be off. Nothing is ever perfect. So the residual plot looks okay, even though it looks just wide and nonsense. You actually kind of want your residual plot to be nonsense a little bit. So questions 8 through 10. All right. So going to question 8. Use a point on the graph to estimate the line of best fit for the given scatter plot. So in this case, instead of using Google Sheets, what they want us to do is they want us just to calculate the slope using our slope formula with the points 3, 8, and 7, 6. Calculate that slope, and then you're going to plug in the point slope equation. So this is going into just calculating an equation just by hand, which we've done in previous units. So this is using the slope formula, using the point slope equation of a line, calculating and reorganizing it, and then getting it into a slope intercept form. Question 9. I know you guys are still staring at the spreadsheet. I apologize. It's just not switching with me. And then question 9 is just you're predicting here. And question 10, use the line of best fit to estimate the original volume of liquid. That means you're plugging in 0 for x. That'll be time. So the original value would be at time 0 or x value 0. So, but the key to this, I think the key important piece that we need to know how to do is to get our x and y data into a Google Sheet. Unless you have a graphing calculator, if you have a graphing calculator, Apex gives you the steps of how to use that. So that's a great option if you have access to one. But if you don't have access to a graphing calculator, this is the way we're going to want to do it. And you just insert your chart. You make sure it's a scatter chart. Make sure you select your x and your y data. Make sure you get a trend line. You want to use the equation under the label, and you want to show your R squared.